Hi, this is Professor Buckwalter, and everyone seems to have a problem trying to decide whether it's a permutation or a combination. Order is important for a permutation, and order is not important for a combination. Here we have an example of 5 people: A, B, C, D, E. Anne, Barb, Carl, Dan, and Eve. And 3 people are needed for the president, the secretary, the treasurer. It's important who we choose to be the president, followed by the secretary, followed by the treasurer. This will need to be a permutation. Think about this permutation thing a little more. If it's Anne's the president, Barb's the secretary, and Carl is the treasurer, it's different if Barb is the president, Anne is the secretary, and Carl is still the treasurer. It matters the order that they're chosen. But when we think about a committee of 3 people and they get together and meet, Anne, Barb, and Carl, it doesn't matter. They're the same 3 people in this committee, so this would be a combination. These are some possibilities if we had a president and then a secretary and a treasurer. So we could have Anne, Barb, Carl, Anne, Barb, and Dan being the treasurer, Anne, Barb, and Eve being the treasurer. Or maybe Barb didn't make it at all, so we have Anne the president, Carl's the secretary, and Barb's the treasurer. See, we have all the possibilities only if Anne is the president. But that could be the case also for Barb, Carl, Dan, and Eve. If they were the president, we could have all these possibilities. We have 3, 6, 9, 12 different ways if Anne is president, and we have 5 possibilities for the president. That would be 5 times 12, or 60 ways. Okay, remember, if order matters, you use a permutation. So, since order mattered, we have a permutation of 5, choose 3, which will be 5 factorial over 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. This reduces, and we have 20 times 3, or 60 ways. Do you see? The 60 ways can be calculated with a permutation formula when order matters. If we think about that committee of 3, you have 5, choose 3. That would be 5 factorial over 2 factorial times 3 factorial, which is 5 times 4 times 3 times 2 times 1, all over 2 times 1, 3 times 2 times 1, reduces, and the 2 divides into the 4, and this is 10 ways. Only 10 ways that we can have this committee of 3 from 5 people. And here you can maybe see it. We have duplicates. Here's a duplicate of ABC, but we should have an ACB also. Can you see they're the same people? We have Anne, Barb, and Carl, or Anne, Carl, and Barb. It's still the very same committee. And we were only looking at those possibilities with Anne being president. But if Barb was in that whole list that we didn't write out for the 60 different ways, we could have a Barb being the president, the Anne being the secretary, and Carl. Or Barb, Carl, and Anne. And here again you can see another example where these would be the same 3 people. So you can see with a committee there's only going to be 10 different ways because we get all these duplicates. Hope this example cleared it up a little bit more about when to use a combination and when to use a permutation. Keep practicing and it'll get easier. Ask questions if you still need some more help.